let's talk about psilocybin. And again, today we're going to focus specifically on psilocybin, and we're going to set aside all the other psychedelics for future episodes. Psilocybin is what's called a tryptamine. That refers to its chemical composition, not to the so-called psychedelic trip. In fact, it's spelled differently. Tryptamine is T-R-Y-P, trip, T-R-I-P, of course. Tryptamines include psilocybin, but also things like DMT and 5-MeO-DMT. The tryptamine psychedelics very closely resemble serotonin itself. That's right. Most of you have probably heard of the chemical serotonin. And serotonin is what's called a neuromodulator, which means your brain and body naturally make it, and that it modifies or changes the activity of other neurons and neural circuits. And it does that generally by either increasing or decreasing the activity of those neural circuits. If I were to show you a picture of the chemical structure of psilocybin or its active derivative, psilocin, and I were to also put right alongside it an image of the chemical structure of serotonin, provided that you weren't a chemist who really likes to focus on the detailed differences between things, you would say those look very similar. And indeed, psilocybin and its active form, psilocin, are very similar structurally and chemically to serotonin itself. Now, as I mentioned before, serotonin is something that you naturally make. And yes, it's true that about 90% of the serotonin in your brain and body is manufactured in your gut. However, contrary to popular belief, the serotonin in your brain is not manufactured from the serotonin in your gut. You have separate independent sources of serotonin. That is, you have particular neurons that make serotonin in your brain. You also have serotonin in your gut, and those work more or less in parallel, separately. Now, what does serotonin do? This is really important to understand because of the similarity between psilocybin and its active form, psilocin, and serotonin. Serotonin, in that it's a neuromodulator, changes the activity of other neurons, and the net effects of those changes are things that you're familiar with. For instance, satiety, or the feeling that we've had enough of various things, such as food, or a social interaction, or sex, or pleasure of any kind. Serotonin is involved in all of that, and an enormous number of other things, such as mood regulation, such as our sense of pleasure itself or lack of pleasure, such as whether or not we feel motivated or not motivated. It works in concert with other neuromodulators such as dopamine and epinephrine and norepinephrine. In fact, if this were an episode about serotonin, which it is not, you would soon realize that serotonin is involved in so many different functions that impact our daily life. And that is one reason why certain antidepressant medications, which alter, either increase or decrease, the amount of serotonin transmission in the brain, will often have a lot of side effects related to things like mood, libido, appetite, sleep, etc. It's because serotonin is involved in so many different things. And serotonin is involved in so many different things because there are a lot of different so-called serotonin receptors. Serotonin is a chemical that we call a ligand, and the chemical ligand is simply the thing that plugs into the receptor for that chemical or ligand. The receptors, in this case serotonin receptors, have the opportunity to do all sorts of different things. They can change the activity of neurons, making them more active or less active. They can cause growth factors to be released, making sure that those neurons reinforce or even build up stronger connections so that they're more likely to be active in the future. Serotonin binding to particular receptors can even change the gene expression in particular cells, making those cells proliferate, so make more of them, making those cells more robust, making those cells interact with new elements of the brain and body. Basically, serotonin and all these different receptors that it binds to has dozens, if not hundreds, and maybe even thousands of different functions. So the fact that psilocybin so closely resembles serotonin leads to a very important question that we should all be asking ourselves, which is, why is it that psilocybin, which looks so much like serotonin, when one takes it in the form of magic mushrooms or some other form, maybe the synthetic form of psilocybin itself, which nowadays is manufactured in laboratories and placed in different psilocybin-containing foods and pills, etc., why that leads to complex yet fairly circumscribed sets of experience, like visual and auditory hallucinations, changes in particular thought patterns, and neuroplasticity that, in many cases in the clinical setting, provided things are done correctly, improvements in mood, relief from depression, relief from various compulsive disorders, etc. Right?